The fourth true and false quiz. If derivative of a function is negative for all x in an interval 0, 1, then fx is decreasing on 0, 1. This is a true statement. This is precisely the increasing decreasing test from section 3.3. Now is the time to look at section 3.3 and review it yourself. Okay? If the derivative is positive, you are increasing. If the derivative is negative, your function is decreasing. True. If a function has a local maximum at C, then f prime exists and is equal to 0. This is false. You see, if a function, so here is a function, it has a maximum at 3, right? But f prime does not exist at 3. Why? Because this is pointed. It is not smooth. So it is not differentiable. The point is, if a function f has a local maximum at C, or actually local minimum, and if the derivative exists, then derivative is 0. But you're not guaranteed that the derivative would exist. For example, sharp points. If the derivative does not exist, then my statement is false. Okay? So this is the graph of negative absolute value x minus 3 plus 5. Check for yourself. It's like absolute value, but shifted right 3 units with that minus, then flipped upside down because of that minus outside, and then raised 5 units. Okay? Next, if a function has a local maximum at C, oh, this is the one we just read. So this is false. All right. Derivative of f plus g is derivative of f plus derivative of g. That is true. These are derivative properties. Okay. Review section 2.3 at this time. Look at this at your notes, or you see, this is the time to review properties of derivative. Okay, this is true. If f of x is e squared, then f prime x is 2 times e. That is not true. This is false. X is the function, x is the independent variable for this function f. So what does f prime means? It means derivative with respect to x. X is my variable, not e. In other words, this quantity e squared is a constant, so its derivative should be 0. Okay? If fx is e squared, then the derivative of fx has to be 0. E squared is a constant. So the claim here is false. All right, everything is correct. Evaluate the limit if it exists. If a limit does not exist, type does not exist, DNE. H approaching 0, square root 9 plus h minus 3 whole over h. First substitute h equals 0. What happens? I get square root 9 minus 3 over 0. What is square root 9? 3. So this quantity gives me 3 minus 3, that is 0 over 0, which is undefined. And 0 over 0 tells me that I need to simplify it. So in case of square roots, the thing to do is consider its conjugate. That is, convert the negative to a plus. Multiply numerator and denominator by the same quantity. Okay? What's the point of this? You have a negative here and a positive here. So this calls for difference of squares. Square of the first minus square of the second. That's what numerator is. Denominator cannot be simplified. I've simply written it like this. Notice square of square root. gets rid of the square root, and I get 9 plus h minus 3 squared is 9. So 9's get cancelled. I have only h in the top and this quantity in the bottom. Notice h cancels the h. H's have gone away. Now I am only taking limit, nothing upstairs means 1 upstairs, and this other factor downstairs. Now when I let h approach 0, I get 1 over square root 9 plus 0 plus 3. Square root 9 is a 3, so 1 over 6. All right. Until next video, let's stop for now.